All right, let's get weird with a question from Steven. Imagine one day, every single human just vanishes. Poof, gone. A silent planet. But our stuff is still here. Our machines are still running. So Steven asks a brilliant, spooky question. When does the last artificial light finally go out? Okay, the obvious stuff first. Most lights will die almost instantly. Why? Because our massive power grids are incredibly fragile. Without us, power demand would drop, sure. But our fridges and lava lamps are still humming. They're still thirsty for electricity. Let's start with the big guys. Fossil fuel plants. They power most of our world. They need a constant supply of coal and oil. And guess who delivers that fuel? Yeah, us. Or who used to. Within hours, these plants would starve and shut down. This would throw the entire grid into chaos. Other power sources would get overloaded. Even with human engineers, this is a nightmare to manage. Without them, it's a guaranteed catastrophe. A rapid, cascading failure. Think of it like cosmic dominoes falling, resulting in a near-total blackout across the globe. But wait, you say, what about nuclear power? Good point. Nuclear reactors don't need constant refueling. A single cube of uranium packs 6 million times the energy of the same-sized cube of coal. One reactor operator told me their core could run almost forever if it just settled into a low-power mode. Sounds promising, right? While the fuel is there, the reactors are built with a failsafe. They are designed to be cowards. The second anything goes wrong, they scram. They trigger an automatic shutdown. Every single component is wired for this. A failure means shut down now. And what's the most likely failure? The power grid collapsing, which we just discussed. So, our nuclear giants would go to sleep very quickly. But wait, plenty of lights aren't on the main grid. Let's hunt down these lone survivors. Many remote islands and communities run on diesel generators. These will chug along happily until their fuel tanks run dry. That could be days, maybe even a few months. Off-grid stations without a human fuel line are better bets. Geothermal plants, for instance. They tap into the Earth's own heat. They could run for quite a while on their own. But here's the catch: maintenance. I looked up the schedule for a plant in Iceland. Every 6 months, they need an oil change for the gearbox. They need to re-grease motors and couplings. Without humans to do this dirty work, some might last a few years, but eventually rust and decay will claim them all. Wind-powered lights would probably last longer. Wind turbines are built to be left alone because climbing them is a massive pain. So they're designed for low maintenance. Take the old Gedser wind turbine in Den Steven. A relic from the 50s. It ran for 11 straight years with zero maintenance. An absolute workhorse. Modern turbines are rated for about 3 years without service. No doubt some lucky one would spin for decades. And it would probably have a tiny little status LED on it. A lonely blinking light. But eventually, its enemy is the same as the geothermal plants. The gearbox would seize up from lack of grease. What about the power of falling water? Hydroelectric dams are mechanical beasts. An operator at the Hoover Dam said it would run on autopilot for years. But with the grid down, all that electricity has nowhere to go. Ultimately, the dam would choke on clogged intakes, or its machinery would just wear out and break. Battery-powered lights? Not a great contender. They'll all be dead in a few decades max. Even a brand new battery on a shelf slowly loses its charge. It's called self-discharge. Some are better than others, but even long-life batteries only last a decade or two. This brings us to our most promising candidate: solar. There are countless off-grid solar-powered things out there. Weather stations, remote buildings, those emergency call boxes you see on lonely highways. They often have a small light on them, on at night, off during the day. Like wind turbines, they're built to last. Solar panels themselves can survive for a very long time, as long as their connected electronics hold up, and as long as wind or rain keeps them clean. In a dry desert with well-built circuits, a solar light could easily shine for a century. This could be it, the last flicker of human ingenuity. But the real champion is a total dark horse. Something truly strange, our spent nuclear fuel. Now hold on, radioactivity isn't usually visible. That's why we have all those scary warning signs. You might think of old-timey glowing watch dials. Those used radium to make phosphorescent paint glow. The glow came from the paint, not the radiation itself. Once the paint decays, the glow is gone. But the dial is still dangerously radioactive. But that's not the only way to make radiation visible. When certain radioactive particles shoot through materials, like water or glass, they can create a flash of light. This is called Cherenkov radiation. It's a kind of optical sonic boom. It's that eerie, iconic blue glow you see in nuclear reactor cores. Some of our most hazardous nuclear waste, like cesium-137, is melted down and mixed with glass. This cools into a solid, stable block. It's then wrapped in more shielding for storage. But in the dark, those glass blocks glow. They glow a brilliant, haunting blue. Cesium-137 has a half-life of 30 years. This means after 2 centuries, those blocks will still be glowing at 1% of their original brightness. The light will fade very slowly, but the color will remain the same deep blue. And so we find our final haunting answer. Centuries from now, deep inside forgotten concrete vaults, the light from our most toxic waste will still be shining. Dear viewers, thank you for being here. Stay tuned to the channel for tons of exciting videos. Don't miss out. Comment, share, subscribe, and hit that like button.